Welcome to Chapter 5, where we're going to begin our discussion by talking about Dalton's atomic theory. And our goals are, well, one, for the section to identify the main features of Dalton's theory, and then state the meaning of or draw conclusions based on the law of multiple proportions. So, as early as 400 BC, Greek philosophers proposed that matter consisted of tiny, invisible particles, which they called atoms. In 1808, chemist John Dalton revived this concept, and his theory, Dalton's atomic theory, is what we're going to be talking about today. So this theory attempted to bring two ideas together, which is the law of definite composition, which states that the percentage by mass of the elements of a given compound is always the same, and the law of conservation of mass, which states that in a chemical change, mass is conserved. It's neither created nor destroyed. And this is something we already talked about, I believe, in Chapter 2. So in this chapter, we're going to try to dive deeper into those concepts. So here's a summary of Dalton's theory. The first point is that each element is made up of tiny, individual particles called atoms. Second point is that atoms are indivisible. They cannot be created or destroyed. And then the third point is that all atoms of each element are identical in every respect. The fourth point is that atoms of one element are different from atoms of another element. So obviously a hydrogen atom is going to be different than an oxygen atom. And then atoms of one element may combine with atoms of other elements, usually in a ratio of small whole numbers to form chemical compounds. And we saw that in a previous video when we were talking about water and representations of matter, and how there's two hydrogen atoms and one oxygen atom. So again, we're just kind of diving deeper into those concepts. So this is kind of a summary of everything I just said, but in pictures. So an element is made up of atoms. All atoms of a given element are identical. So let's say this is a chunk of the element platinum. Okay, so this would be a platinum atom. Okay, so, and that's something we've seen previously again. So this is just, again, going into those concepts in more detail. Atoms cannot be created or destroyed, especially with a hammer. All atoms of one element have the same mass. Atoms of two different elements have different masses. And then atoms of different elements may combine in the ratio of small whole numbers to form compounds. So these are key features of Dalton's atomic theory. Okay, so how does this apply to chemical reactions? So before the reaction, remember our reactants and products. So these are the reactants. So before the reaction, the reacting substances contain a certain number of atoms of different elements, represented here in red and blue. As the reaction proceeds, the atoms are rearranged to form products. Okay? Over here. The atoms are not created nor destroyed, but they simply are arranged differently. Okay, that's a key feature of Dalton's theory applied to chemical reactions. So the final thing that I mentioned at the beginning of the video was this law of multiple proportions. And it says when two elements combine to form more than one compound, so in this case we have carbon monoxide, which is one carbon atom, one oxygen atom. And over here we have carbon dioxide, which is one carbon atom and two oxygen atoms. So when we have this, when two or more elements combine to form more than one compound, the different masses of one element that combine with the same masses of the other element are in a simple ratio of whole numbers. So for example, we have for carbon dioxide, 1 carbon and 2 oxygen ratio, or in carbon monoxide, a 1-to-1, okay? So in other words, this has twice the mass of oxygen in it, or oxygen atoms, okay? So that's all it's talking about here. It's a simple ratio, not half an oxygen atom more, it's twice the mass of oxygen more, okay? Or twice the oxygen atoms. So that's pretty much it for this section. And in the next section, we're going to be continuing our discussion on the atom.